Right. Okay, so let's start with 5.5. Okay, here we go. So in 5.5, we're going to talk more about solving polynomial equations. So you learned how to graph, let's say, you learned how to factor quadratic equations, right? Today we're going to go into a little bit more, variety. Okay, so when we were solving when we were solving quadratic equations, we learned difference of two squares, and we learned the perfect square trinomial, right? Where like difference of two squared, you would factor, let's say, x minus 3, x plus 3, right? So if you had x squared minus 9, it would factor like that. Remember that? And then for the perfect square trinomial, if you had, let's say, x squared minus 10x plus 25, remember, you would say perfect square. That was x minus 5 squared. So we learned these two patterns. Okay, now let's focus on this first one, where I have x squared minus 9. Do you see how in that case we had a perfect square with a minus in the middle? Okay, now we're going to take that and we're going to expand it to what if it was a perfect cube and a perfect cube, right? That's what we're going to do now. The difference is, for the case of the square, if there's a plus here, it's prime. We can't factor it, right? But for the difference of cubes, plus and minus can both factor. So let's take a look at what is the formula here. If you have a cubed plus b cubed, okay, you take the cube root of the first one, you take the cube root of the second one. Then we're gonna square the first one, multiply the two together, square the last one, okay? Now, notice there is one negative in this whole thing. If this is a plus, you put the minus here. You always have one negative to spend. So if this is a plus, the negative goes there. Now let's do the case of the, subtraction, a cubed minus b cubed. Again, take the cube root of the first one, take the cube root of the second one, square the first, multiply the two, square the last. Now, you remember you always have one negative to spend? If there is a negative here, you spend that negative there, then you only have positives the rest of the way. Okay. All right. Let's take a look at this for a minute. So let's talk about cubes, right? Let's talk about cubes. What is 1 cubed? 1 times 1 times 1, that's 1. 2 cubed, 2 times 2 times 2 is what? 8, right? 3 cubed, 3 times 3, 27, right? So these numbers, 1, 8, 27, these are perfect cubes. And if I were to take the cube root of 8, it would be the 2. And the cube root of 27, it would be the 3, right? Okay, so let's go over here and let's take a look at this one. You notice, okay, this is a x cubed, that's a perfect cube. Hey, 27 is also a cube, right? So what we're going to do is the following. Take the cube root of both of them. X cubed becomes x. And what does it mean to take the cube root of 27? Basically, find the number that when you multiply it by itself 3 times, you get 27. That number is 3. Now, if there is a negative here, there is a negative there. Okay, next. All right. Square this one, x squared. We wasted all the negatives, so now it's a plus. Multiply those by each other. Ignore the negative. 3 times x is 3x. Square this one, plus 9. Oh, my pen froze. All right. Let's take a look at this next one. So that's the final answer there. Sometimes this blue one might factor further, but this one doesn't. Okay. So let's go to this one. Perfect cube, perfect cube. Now, the cube root of 64 is 4. Okay, what if you don't know that, right? You can always do it with your calculator. So why don't you go ahead and take out your calculators, turn them on to the home screen. So that would give you a 4 and a y. Okay, now, if you have a plus here, you got to have a plus here. Now, let me erase these and get it out of the way. So the cube root question is you got it? All right, next, in the other parenthesis, we're going to square this one, 16. Now, have we used our negative yet? No, we use it here. Multiply the two of them, 4y, plus this squared, y squared. Okay, so square the first, multiply, square. Square the first, multiply, square. Okay? Huh? It's like a sandwich, exactly. Okay, so let's do the next one. Here, I have an 8. Is 8 a perfect cube? It is. It's the cube of 2. And 125 is 5 cubed. Okay, so here, first I take the cube root of the first one, 2a. The cube root of the second one, 5b. Does the middle get a plus or a minus? Minus. Now, in this parentheses, do I have any negatives for the second? No. Okay, so look, I'm going to square the first one. When I square this, what does that give me? 4a squared. Then I'm going to multiply these two. When I multiply these two, what do I get? 10b plus 10b. Then, oh boy, 10ab. Because, okay, so last, now I need to square this. So that will be 5b squared, 25b squared. Okay, not too bad, right? Okay. Ooh, what about this mess here? It looks like we can factor some stuff out, right? What can we factor out? A 3 more than an x, x squared, right? I can factor out a 3x squared before I even get started. So from here, I get 8x cubed plus y cubed. Oh my God, now I have sum of cubes, right? So this 3x squared gets copied over. And now I got to factor this. So what will be the cube root of the first term? 2x plus y. Okay, now square this guy. What do we get? 4x squared. The next term, is it going to be a positive or a negative? Negative, because I haven't used up a negative yet. Multiply these two together, 2x times y. Lastly, plus square this, y squared. So again, square the first, multiply the two, square the last. 2x times y. Perfect cube, right? Cube root of 8 is 2. Okay. All right. We're good with this? Yes.
So 4a squared isn't like the perfect, or isn't it like 2?
Hmm?
If you said like perfect square, but isn't like 2?
Perfect cube. Huh?
Okay, so like you said 2x is the perfect square, right?
No.
You said like you can take it out of the 8x. Yeah.
It's the cube root, yes.
So for 4a square, can't you take like the cube root and would it be 2?
No. This one here, the 4a squared. Oh, we got that by squaring. So by then we're done. Okay? We got that because we squared. We had already taken the cube root of this, and then we squared it and we got that. So we can't go further. It's done. Okay? All right. So let's go here. Okay, these are all the different ways you've now learned how to factor, right? You know how to take out a GCF. If you have, two terms, you've learned difference of two squares, cubes, and so on. All right, the next thing we're going to practice is grouping. If you have 4 or more terms, you can factor by grouping. So take a look at this one, example 2a. 1, 2, 3, 4 terms. When you have that, you have to try factor by grouping. Okay, so how do we factor by grouping? You have 4 terms. You split this down the middle. All right? Now, from the left side, what can I take out? An a. And I get a plus 3y. You know what? Let me do this. Okay. Plus, from here, what can I factor out? 2y squared. And I get a plus, oh my gosh, 3y. Take a look at that. Do you see how you have identical things in both terms? You have learned this in Algebra 1. You have identical things in both terms. You write that off to the side one time. Don't question me on this, just do it. Now, what do you have left over that you haven't used yet? A plus 2y squared. That goes here, and you're done factoring. Okay? That's it. So the trick is write whatever is the same down one time, collect what's remaining, and put it here. That's it. I love these as well. Yes. Okay, let's take a look at this one. Let's factor this by grouping. Split it down the middle. Okay, I'm going to take out an x squared, right? I have what? Y squared minus 4. Now, from here, I can actually factor out nothing, right? But what I can do is I can take out a negative 1. When I take out a negative 1, what do I have left? Y squared minus 4. Oh boy, look, the same term again. Okay, so from here, because this was a minus, I just took out a minus 1, made this y squared minus 4. Okay, now, the term that's the same gets written down here once, just once. What have I got left over? X squared minus 1. Now, am I done factoring, or can these factor further? Oh my God, they can totally factor further. Because the y squared minus 4 can factor into what? Yes, y plus 2. And what about the x squared minus 1 though? No. Yes. X plus 1, x minus 1. And now we're done. Talk about a mega factoring problem. Yay. Okay? Okay. So now here we have like a wild card. What do you think? What do you think? How many terms does this have? Are you sure? 2. 2 terms. So look, guys, put your calculators down for a minute. Look here. I'm going to show you why I put that chart up there. This has 2 terms, right? X cubed 216. Go up here. Number of terms, 2. If you have 2 terms, here are the different things you can do to factor. Now, is this a difference of 2 squared? Is it a perfect square, perfect square? Is 216 a perfect square? Let's try it out. Take the square root of 216. Do you get an integer?
Yeah.
What do you get? No. It's not a perfect square. Is it? Okay, so now, is it 2 cubes? What is it the cube of? Mm-hmm. Right. So we're going to factor by cubes. Okay? So, x, plus 8. What is the cube root of 216? I'm sorry, 6, sorry. Times. Okay, now, square the first one. Okay, the next one, is it going to be minus or plus? Minus what? 6x. Plus, square the last one, 36. But now, look at the instructions here, guys. It doesn't just say factor. It says factor and solve. And if you look at this, it's not just x squared, x cubed plus 216. There is an equal to 0 here. So I got to set it equal to 0 there. Now, none of these can factor any further. Okay? I'm going to take your question after I finish this problem. Okay. None of these can factor any further. So, I still have to solve these though. Okay? So take a look. Can I set this equal to 0 and solve? Of course I can. I get x equals negative 6. Now, can I set this equal to 0 and solve? Well, there has to be a way to solve it. So back in the previous chapters, in chapter 4, we learned how to solve by factoring. But when that didn't work, we learned some other things. What are some other things that we learned? Quadratic formula. Yay! Or you can do completing the square. Yes. What's the t-chart? It doesn't. You can try, but because I know what's coming, I'm telling you there are no 2 numbers that multiply to 36 and add to 6. I promise. Take my word on this. Yeah, I mean, like the quadratic formula always works. Or you can do continuous square. That's the thing. Okay, so let's do the quadratic formula. Yay! X equals negative b plus or minus the square root of b squared, that's 36, minus 4ac all over 2. Huh? So it's minus b. What's b? So negative b is, okay, b is negative 6.
Oh, b squared.
B, okay, yes. So this is negative b. Plus or minus b squared, that's 36. Minus 4, a is 1, c is 36 over 2. Okay, so now x equals 6 plus or minus the square root of. Okay, so with your calculators, what's 36 minus 4 times 36? Negative 108. Do it again. 36 minus, okay, negative 108 over 2. Okay, so what are we going to do about the 108 now? Let's see what we can do. It's a negative, so the I is going to come out. Okay, let's do things one by one. Okay, guys, one step at a time. So the 108, 2 and 54. Okay, let's do it again. 2 and how many? 27. Now, 3 and 9, 3 and 3. Okay, so let's see what comes out. a pair of 3's come out, and a pair of 2's come out. So let's go back here. This is going to be x equals 6 plus or minus 3 times 2 comes out 6I root 3 over 2. Now, can I divide by 2? Yes, I can. So this will be 3 plus or minus 3I root 3. Okay, but remember in chapter 4 study what we learned. You have a pair of 2's comes out as a single 2. You have a pair of 3's comes out as a single 3. 2 times 3 is 6 root 3. Okay, so now I have 2 answers here, and I have 1 answer there. So altogether, x equals negative 6, x equals 3, plus or minus 3I root 3. Okay,